Okay, good afternoon. Okay, so here's the prototype or sort of the objective for today's lecture. We'll do this about an hour, siguro, and then you could follow along. I have 30 minutes to spare after this. But yeah, the goal here is by the end of this two-part lecture, no, one today and then one's a Thursday. So the goal of this is to have instantiation or creating objects, no, through code instantiation, as well as collisions, handling collisions. So what I have here right now, so I'll play this one. I have a farmer or a player here at the bottom. We could move this with A and D. We could move objects through scripting. We've already done that in Unit 1, right? However, this case, we're only moving at the x-axis, no horizontal axis, and then we don't have up and down, so just side to side. We also have different animals spawning from above and then going down. But there are no collision detections here, not right now. We'll do that next lecture. What we also have here for the player is we can throw food. In this case, it's a piece of meat flying from the player and then um, towards the animals or towards above. Anyway, so that's it. So that's sort of our goal for today. Okay, so I'll close this and then we'll start from scratch. So you could create a 3D project with for your if you want to follow along. Okay, so I'll close this one and then I already have this created before. I'll just remove this one. Uh, stop. And then what I want to do here is I'll separate the game view, which is this one, and the scene view. This layout is, I think, tall. You can use other layouts if you want, whatever you're comfortable with. But for me, I'll be using this layout. I think it's called tall. And then I'll separate the game view and the scene view for later. Okay, it's easier for later. Anyway, if you've downloaded the assets, you could import the package, right? So go to assets and import package. I've already downloaded it before, so I'll just import it again here. Okay, we'll just import everything, and then it takes a bit to import. Okay. So there we have the course library folder. So we'll have the assets from Unity there. And we also have the scenes folder. So when we started our empty project, we have the sample scene, but we don't really need sample scene. We could do double click on prototype 2. This is the scene that we will be using. Okay, so we have our main camera, directional, environment, etc. So under environment, we just have the ground, the left border, and the right border, right? Right now, our camera just looks like this. So if you want to see what the camera does or what our camera is situated like, it's here, right? Sa baba. Okay, so it's above. It's just directed downwards. But I think this is a bit too small. Maybe we could zoom it out, right? You could move our camera up and down to zoom in and zoom out, essentially. I'll just zoom out until I reach the point where there is a no more. It is zoomed out. Oops, sorry. Zoomed out na wala siya sang black border. So right about there would be good. So we have a better field of view. We have more areas to move around. Okay, so that's just for the camera, and then we'll add some elements to our game scene. Okay, I'll do it like this, where it is top-down perspective as well, and then I'll do orthographic, so it ignores perspective view. Okay, anyway, so under assets, under course library, we have different folders here for different prefabs. So we have animals prefabs, which we can use later. We have food prefabs here. And we have humans and materials as well. So under humans, we have a lot of prefabs here. We can use a lot of these for some. So all these prefabs, you can choose whatever you want as a player. We'll just choose one random here, maybe this one, Simple Farmer. So you can inspect the prefab actually here, so inspector, right? So we'll use this. I'll just drag it directly to the scene. Okay. So right now it's currently there. It's flying in the scene, right? So we could change the XY position. So I'll just change the X position to 0, the Y position to 0 as well. So now it's on the ground. And maybe, well, we'll situate it maybe around here at the bottom part of our game, right? Maybe around here. Let's say minus 3z para whole number siya, right? So it's a whole number. And then we'll move it in the x-axis around here, like so, right? So we'll do that with scripts. Okay, so under assets folder, I'll just create another folder for scripts. So I'll have another folder here for scripts to keep things organized. And then I'll create a new C# script, right? So since this is player movement, I'll just name this script player movement. Okay. So what do we do with our movement? Well, we need fields for um, that concerns player movement. We don't really need anything in the start, so I'll just delete the start. What we want is a field or a serialized field for public private for movement speed, right? So we can tweak it in the inspector, and then we'll also do. Is this wrong? Serialize field. That's 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 right. Okay, for move speed currently. Okay, and then under update, we'll look for input, right? User input. We could still use the user input that we did early before. So under edit project settings, we could still use the axes, no, here. So I'll just use horizontal again for now. So easy, we'll just do float x input, for example, is equal to input dot get axis horizontal. Horizontal. And then we'll just multiply this. Vector 3, move distance is equal to, nope. So this one will be equal to our move speed multiplied by our x input multiplied by time delta time. This is for again to have the frame rate dependence. No, we don't need to be dependent on the frame rate. And then we multiply this with what axis are we using here again? X-axis. So that's vector 3 dot. So we could use right now, which is 100, or left, which is -1. But for now, we'll do right. We don't need to invert the controls. So I'll use right. Okay. And then we'll attach this script to our player or our farmer here. We could rename this farmer to keep things organized or to make things simpler, rather. And then I'll add the component here, um, player movement. Okay, and then I'll set move speed to around maybe 25, 35 maybe enough. Okay. So if I click on play, so what we expect here is if we press A and D or left and right, our player will move from left to right. It's not doing it. Hmm. I forgot the translate. Sorry. Transform, translate. That's So for this unit, na unit 2, two-part lecture na siya, we'll still be using translate for motion, pero unit 3 will be using forces na. But for now, we'll just use translate for motion. Okay? Keep things simpler. There. So it moves from side to side. However, if you move too much to the side, there it disappears from the screen, and then there it also disappears from this part of the screen. So we don't really want that. We want to keep our player inside our screen. In this case, in this game, we don't really want our camera to follow the player along. We just want that our camera stays put, but then we'll just limit the movement of our player. So in this case, we could move the player to wherever we want to limit its motion, maybe around here, maybe so that's around negative 20, right? Or negative 21, our whole number, right? And then so that's our minimum left, minimum x limit. And then we'll have here around 21 as well as our positive x limit or x max or x min. And then we'll do fields here for x limit. So I'll say x min and x max. Okay. So we could limit our movement by having an if statement. Pero another way to do this is to use clamp or the mathf.clamp na function. The mathf clamp function returns a value na there's a minimum and a maximum, and that value can't go over minimum maximum, right? So I'll say float x limit here, for example, is equal to the dimension we're concerned here is the x position, right? So we'll get it from transform dot position, and then we'll just get the x, right? Oh, I forgot. So this we will feed it to our math f dot clamp function. So our clamp function needs three parameters. One is the value we are clamping. Next value is the minimum. So we'll just put x min here. And then finally we have x max. X max. Okay. And then, so that's just, we're just getting the value, the clamp value of x, but we still have to apply it to our transform. But our transform, we can't really edit the x position by itself. We need to actually transform the whole position, right? Or edit the whole position. But we just want to edit the x position. But to do that, we could access our transform position, transform dot position. So this is a vector 3 because we can't do transform dot position dot x is equal to x limit, right? That's what we want to do, but C Sharp and Unity won't allow us to do that. Instead, we will feed a new position. In that new position, we could use a vector 3 because essentially it is a vector 3, right? Three values. So new vector 3. And then the first value here is the x. And what we want to use here is the clamped value, right? X limit here. And then for y and for z, we don't really want to touch y or z, right? We could just say that this is still the same position, or this is still the same x and y value. So we could just call transform dot position dot y, and then this is transform dot position dot z. Okay, so what we have here essentially is in this line 19, we are clamping the value of our x position so it doesn't go over the minimum or below the minimum or over the maximum. And then we are changing the position of our game object itself na clamp na ang x so it doesn't go over, right? But we keep the y position and the z position because we don't really want to edit those. Okay. So let's see. Let's go back to Unity. Our X-min, what was it before? Negative 21. Yeah. So that's minus 21. And then our X max is 21, around 21. Okay. So now, if we click on play, and then let's move from side to side. There. So whenever I'm still pressing D, it clamps the X position and then it forces our player to stay in that X position instead of going over. Right? Same thing here. So clamp siya at negative 21X. There. It stays in the screen. You can also do this with colliders, but since we're using translate, it doesn't. The collision doesn't really work too well. No, with translate and uh, collision. If we're using forces, pwede siguro. But for translate, it's better to clamp it instead of using colliders. Anyway, so we can move our player left to right. There is no up and down, right? That's enough for our player for now. Next thing we'll do is the food that we're going to throw by the player. To do this, we'll choose the food first, right? We could go under the food folder, and then there are a lot of presets here. We have carrot, a pizza, sandwich, steak. Well, the previous example I used steak, right? But maybe we could use something else. Maybe we could use a banana, like here. So I'll just drag this into the scene. So it's there, it's floating, the shadow's over there, and it's a little small, right? I'll reset this transform so it's 0, 0. And then maybe to make it more visible, I will just scale it, right? So I'll scale it in the X, Y, Z axis. It's a bit too small, so maybe I'll scale it around 3 there. Much bigger, right? Much visible for now. Okay. And then what we want sa food is it moves from in the z axis. It moves forward essentially, right? So it just moves like so, like it just moves like that, right? So, yeah. So for that, we could just do this with scripts as well. So since it's moving forward, we could just make a script that says move forward. Or you could say banana, pero essentially it's just moving forward. So I'll just say move forward. Maybe we could use it uh, again next time. This food banana, I will rename to just simply banana. And then I'll attach a script, move forward sa banana. There. And then we'll edit this script. So for this one, we just want this to move, right? In the z-axis. So we'll serialize a field for private float. This is for move speed, right? Move speed. Sige, we'll set it at 0. So to update, what we want here is we just translate, right? We don't have any inputs, so we'll just calculate the motion, move distance. Here is move speed times time that delta time multiplied by vector 3. What axis are we using here? Z. And it's going forward, so we'll just say vector 3 forward. And then transform the translate there. And then we'll just feed the move distance here. Okay. It's as simple as that. And we'll go back to our Unity here, and then just fill in the, oh, sorry. So click on the banana here, and then move speed maybe around 40, 40 maybe 40 is good. Okay. So if I'll move it a bit here para makita ang motion, so you can see the motion. So if I click on play, there it moves, just moves forward, and then it's gone, right? Moves forward, there, it's gone. But well, it's not like we can instantiate the banana during play, right? Like we can't do something like, oh, during play, if I want to instantiate or if I want to create another banana, I'll just drag it from the from the hierarchy or from the assets to the hierarchy, assets to the hierarchy. That's not how we play games. So what we want is to create an instance of this banana when the user presses something, at the command of the user. So we'll look at some input axis that we can use. So we've used horizontal, right? Maybe we could use this one, fire one. Fire one here. Um, it has a positive button, and it has an alternative positive button, which is mouse zero. So if you want, mouse zero is the left click here. Mouse one is the right click, I think, and then mouse three is the middle mouse click. Okay, so mouse zero here is left click. So whenever I click on left click, it will register as Fire 1. So we'll use that axis to have our banana, to spawn a banana, right? And in this game that we're doing, it's the farmer or it's the player that is throwing the food, right? Or throwing the banana. So we could put that inside player movement, the throwing banana script. We could definitely put that in player movement, but I think the better option here is to create another script, right? We create another script just for the responsibility of throwing the banana, right? So I'll create another script. So I'll name this throw food, for example. So the reason why I want this in another script is this thing in object-oriented programming called SRP, or Single Responsibility Principle, where player movement's responsibility is just the player movement, and then throw food's responsibility is just throwing food, right? So separated on responsibility, and if you want to tweak things, right, between scripts later on, if you want to tweak some movement, you don't have to tweak sa throw food, right? So it's compartmentalized. Anyway, we'll attach this throw food kay player, right? There. And then we'll edit this throw food. Okay? Again, we won't do anything to start. But what we want here as a field is a reference to the game object that we are going to throw. Okay? So for that, we could do public, but I usually just put serialize or serialize private field. So I'll serialize another private field. So since we are instantiating a game object, or we are creating a great game object through script, the reference that we want is also a game object. There. Take note, capital G siya. That's because it's the class name, right? And then I'll say this is food, okay? Or much more descriptive, throwable food. Throwable food. Say. We won't instantiate it or anything. We'll do that sa inspector na lang later on. Okay? What we'll do here is update is we'll create that object when the player clicks on mouse one. So we could say if, right, input dot get access. We can use get access, but I'll show the difference later on with get access in another function. What we've been using is get access, right? This is fire1, the fire1 access, and this returns a float, either 0 or 1. So we'll equate this to 1, right? When we click on the positive buttons access, it's 1. If we're not clicking, it's 0. So meaning if we click, then it is equal to 1. Anyway, so um, if we click, then we create instance of food here. So ang instance of food, mayroon na siya movement nga daan. May movement script attached na siya. So we just have to instantiate it and it will just move on its own, right? So to do that, well, usually when we instantiate things sa C#, we use the new keyword, right? New vector 3, new transform, something like that. But for Unity, when we are creating a game object inside Unity, we are going to use the function instantiate. There, instantiate. And then this takes on, there are a lot of overrides with instantiate. You could just instantiate the game object and then it follows everything. But what I usually use is an override of instantiate that takes on three parameters. One is the game object. So I'll just put it there. We'll replace that later. And then the position, and then the rotation. Okay, and then we'll fill this out one by one. So the game object that we want to instantiate is, of course, the reference that we have sa throwable food. There. And then the position, since this is the player and we want this to spawn wherever the player is, we could just say that transform dot position. Position. So this just copies or this spawns wherever our player is, right? And then lastly, rotation. So for rotation, if we want to keep the rotation set for it, usually that's 000, right? We could just instantiate this with identity na rotation. So quaternion here, quaternion is another data type. Similar siya sa, well, it's not really similar, pero somehow like vector 3 na may number of values siya, but I think quaternion has 4, vector 3 has 3. So quaternion.identity here, it's a shorthand no, for the identity rotation, which is just the base rotation, 000 ni siya most of the time. Okay, so what we're doing here is when we click on fire 1, right? Fire 1 get access equals to 1, we will create an instance of our food. Okay, so let's go back to Unity and fill out the missing details, especially um, the food. So if we click on player, right? And then it's a throwable food here, non-Angia game object. Now, we could just drag the banana game object here as a reference. However, what happens if we delete our banana game object from the scene later on? Well, it's gone. We don't have a reference of what we want to spawn. So instead of taking it from the hierarchy, we want to store whatever blueprint of our banana is already. We want to store the settings of this banana, the scale, the script, the mesh, whatever. We'll create a custom prefab, right? For prefabs, that's like a game object na may nakasave na settings. In this case, it has the scale, it has the rotation, it has the script, etc. I'll just create another folder here to store our custom prefabs just to separate it from the prefabs that Unity provides us already. So I'll say prefabs here, or better yet, custom prefabs. Okay? And then, to create a prefab, it's easy. You just click on a game object from the hierarchy and just drag it down to the assets folder. Okay? And it will ask you here, create prefab or variant. So basically, it asks you if this is a variant of a previous prefab because the banana, if you remember, it was a prefab from Unity. So if we click prefab variant, so it's sort of still connected to the banana prefab that Unity gave us. Whenever we do some editing there, it might affect this current prefab. But if we do original prefab, we are severing that link. So this is sort of like an original, a new prefab. Now this prefab, we can then use for instantiation, right? So if we delete this banana, we still have that concept of that banana, right? We could click on player, and this one wants a game object. So we'll just drag our banana prefab into that, and we'll see if it fires bananas now. Okay. Okay, there. So there it fires a lot of bananas. So what happens is if I click, right, that is one. Our update notices that that axis is one, right? So it fires, so every frame it fires one banana. There. So that's not what we really want, right? What we want is when we tap or when we click the mouse button, it spawns a single banana, not multiple bananas. Also, if we look at the hierarchy here, there's so many banana clones. So many, if I actually we can track that's a scene view, it still goes forward on and on and on and on, right? It's never going to get destroyed unless we stop our game, right? That's also not a good thing, right? Because when for projectiles, if you don't destroy them, it clogs up your memory, especially here, it's a hierarchy, it clogs up your memory, and well, your game might be slower moving forward, right? Okay, so let's fix those things, right? Okay, they're gone. Okay, first up, we'll fix the firing, right? Instead of continuous firing siya when we are holding fire 1 axis, we want to do is when we click fire 1, it fires, right? So instead of get axis here, we will say get button down. Okay, so get button down. This returns boolean, so we don't have to equate it to 1, right? So get button down is essentially whenever you press. So the event of pressing. So it doesn't count if you're holding that button, right, or not. Okay. Next thing, okay, so let's test that and then we'll do the destruction after. Okay. So now, let's move from side to side. So if I click, there. If I hold it, isa lang siya gyapon, right? That's more like it. That's what we want. There. Okay. Next thing we have to fix is the banana. Lots of bananas clogging up our memory, right? There are a lot of ways to do this. For the create with code, na for the create with, in the create with code na example, they set up a condition where if this certain thing reaches this certain X position, it will destroy, right? But what I usually do instead is I do timed. May time siya to destroy, right? Okay, we could do that through scripts as well, ang object destruction. So I'll go to scripts. I'll create another script here. I'll call this timed destruction. Okay, so naka-time siya. Okay? So, sa time destruction, what we want to do is, well, we'll serialize a private float here for its time to live. So how many seconds does it have to live? I'll just call this time to live. This is a float, essentially how many seconds it has to live. We could do things in update where we keep track of elapsed time through time.delta time. But a better way to do that is sa start na lang. Okay? What we'll do here is we'll call destroy. Okay? Kinda morbid where sa start pa lang you're already calling the destroy na function. So the destroy function destroys a game object, right? So this has arguments. The first argument is the game object you want to destroy. And we are attaching this script to the game object that we are destroying, right? So we'll just say that it destroys itself. So for that, we'll do game object. So this one gets the game object, no, what that this script is attached to. Again, it's different from this, where that's a class name. Whenever you use game object with small g, it refers to the game object where your script is attached to. Sort of similar to your transform. If you use transform with big letter T, that's the class name, but if you use transform with small letter t, that's the component, right? So similar with game object here. Second parameter here is time to live. So the second parameter here accepts a float for how many seconds ang we're going to give for that game object to be destroyed, right? So it starts and then once it spawns, no, it calls the start and then it will call destroy the game object after time to live seconds. Okay, so essentially it's that. So start is being called again when an object is instantiated or a game object is instantiated. And then for that, we'll just call destroy this game object, right? After time to live seconds. Okay, so we'll attach that to our prefabs or sa prefab let's go to our prefab, custom prefab. So sa banana here, right? We could just add our component. What was it? Timed destruction. There. And then time to live, I'll just say 2 seconds, probably. That's good enough, right? So now, whenever we instantiate this banana prefab, meron siya move forward script and it has time destruction script as well. Okay? So let's play and then let's see how it goes. Okay, so I move left and right still. So if I click, there's a banana clone and then it goes away, right? So if I create a lot of instances after 2 seconds, automatically destroyed siya. You can view it sa scene view, actually, right? If I click on the game. There. It just gets destroyed somewhere here. Yeah, there. Destroy siya after 2 seconds. Okay. So we have our player and we have our food. So again, this part of the lecture wala pa kita colliders. That's going to be next next lecture pa, right? So we have our player now. That I think we're set for the player. Next thing we'll do is the animals going down from the top portion of the screen to the bottom, right? Am I going too fast? Okay na. Anyway, for the animals, we could take a look at the prefabs animals, right? So there's food. No, not food. We have dogs here. So we have a beagle there. We could inspect it. So, inspector, right? Border collie, bulldog. So we have a lot of dog models here provided. I'll choose Saint Bernard. Okay, sure. I'll choose this one, Saint Bernard, working dog. I'll just drag it to our scene. That looks very small. So maybe zero. I'll zero out the position. Maybe put it a little forward here. That seems kind of small, right? Or actually, that's big enough. Okay, I think that's big enough, right? We'll rotate it around 180 degrees so it faces downwards because it goes downwards, right? And we'll select more animals. Maybe we could select a farm animal. There's a chicken here, very blocky chicken, right? Chick. We have a cow, brown cow. We have white, black and white cow, etc. Horses, chicken. Maybe we'll use this white, black and white cow. I'll just drag it to the inspector or to the scene view. I'll zero out the transform for now, and then move it around here. So it looks like our dog and our cow has the same size. So maybe we could change the scaling of this one. Maybe around 0.15. That's chunky. That's a chunky cow there. And then we'll rotate it 180 degrees in the y-axis so it faces downwards as well. And then we'll do one from the forest. We could do, what I used was a moose. Maybe we'll use a stag this time around. I'll drag it to the scene, zero out the position, and then I'll drag it here. We'll make it a little bigger, maybe 15 there. That's okay. And then we'll rotate it 180 degrees. There. Okay. Move this back a bit. Move the dog back a bit, as well as the cow. Okay, so what behaviors do we want for our animals? They just move forward as well, right? So we could just, we'll rename these first para hindi siya too long. For the dog, I'll just say dog. For the cow, just cow. And then for the stag, just stag, like so. And then I'll just add a component, move forward, right? And then we'll just change their speeds. So for the dog, we want this to a bit move a bit faster. So I'll say 15. For the cow should move around slower, around 7 maybe. And the stag is, let's say, around 11. 11. Okay. Like so. And then we'll test. There. So they move at different speeds. Ang animation is already provided by the prefabs, right? We don't have to deal with whatever animations they have. But that's what they do, right? They move and then they're gone. Okay. Uh, so again, similar thing with the projectile. We don't want this to be. We want this scripted, no? We instantiate this through scripts. But also similar with the banana projectile or the food projectile, we want this to die or we want this to be destroyed when the time comes. Sorry, a bit morbid. Uh, no real animals are harmed in the production of this game. Anyway, So we want this to be destroyed whenever it's out of the screen. So we could just use the time to live or the time destruction. I'll just give it around maybe 5 seconds for everything. I think that's enough time for the cow to destroy itself once it gets out of the scene. Okay, but let's test. Right? So the cow moves very slow, but there. End of the scene, and then there. Destroyed. Right? Right? So what we want to do next is to spawn these animals through script, right? We'll create this thing called a spawner, right? If you've played Minecraft, we have like small blocks that monsters spawn from. That's a spawn point or a spawner. So we'll create something similar with that. Um, but first, right, similar with our food, we will get these animals and make a prefab out of it. Para tanan, all instances of our animals, my move speed and my time to live na. And we don't have to um, do that through script again. Okay, so those are prefabbed. That's good. Okay, and then we can delete this, pero maybe we'll just hide it for now. To hide it or disable it, you could just, there's a checkbox here, right? I'll just disable it for now, and then what I'll do is I'll create a spawner. So for the spawner, ang job naman lang is to spawn, right? We don't really need a, what do you call this? A model or a mesh for it. So we could just create an empty object, transform lang siya, and then we'll just attach a script for this. I'll call this animal spawner. Spawner there. And then I'll reset the transform. The problem though with an empty game object is, well, we can't see it in the scene view. So we could do just a stand-in now, for now. We could just do a stand-in, maybe this farmer, We could drag it, and then we could drag it into the animal spawner, sort of like a child of the spawner. So whenever we move our animal spawner here, like so, then our child farmer there will follow as well. So we can see where it is in the scene view. So maybe I'll put it sa XYZ, maybe here, just above the scene. So it's not visible sa scene because we'll spawn our creatures from there. Okay? Okay. And maybe we'll just disable it. We can delete it, we can disable it, however you want. Okay, now we'll have a script for the spawner. So scripts, we'll do another script here. C# script. Animal spawner. Okay, and then we'll attach this to our animal spawner, and then we'll edit this script. Similar with our throw food, no? Similar with our throw food, we want a reference to a game object that we want to spawn. However, multiple ang game objects that we want to spawn because there's a dog, there's a cow, there's a stag, and then you can add pa more if you want later on. So the best way to do this is through an array. I don't really need to explain an array, right? Because, well, you have plenty of experience with arrays na, right? Private. This will be an array of game objects. So, oops, that ain't it. Game object. There. And then to make it an array, well, my brackets lang siya. And I'll call this animals. Okay. Then, uh, okay. I'll have another field here. We want this spawner to spawn animals at a certain rate. So we could say spawn rate, right? So we could have another private float here, and then we'll call it spawn rate. Maybe I'll initialize it at 1 second. Okay, something like that. Now, to update, we want the spawner to spawn every 1 second. So for this, we could have another field here or another variable. But this one, I won't serialize this because this will only be used as a script. I'll call it private float elapsed time. So the elapsed time, we'll set it to 0. We'll just say that when the elapsed time reaches the spawn rate of 1, it will spawn and then it goes back to 0. So essentially the counter siya, right? We could track of the elapsed time with time dot delta time, since time dot delta time is the time between two frames, right? So we could track time with that as well. So sa update, we'll say if our elapsed time is greater than or equal to our spawn rate, right? It means it's time to spawn. Time to spawn. And then after that, we'll just clear our elapsed time to 0. Okay. Now, for time to spawn, we'll spawn. Okay. First, we'll get a random animal to spawn, right? For that, we'll use a randomizer. Ang range of our random number here is, well, depende sa range or depende sa elements ng aton nga array, right? Okay, so we could say int, since indices are int, right? Int random animal index, or just say random index, so it's shorter. We'll do random range, and then from 0 to the length of our animals na array. So length here is just there, length. Okay. So our random range, actually there are a lot of well, there are variants of this overrides. In this case, we are using the int na parameter. So if it is int, we could see the tooltip there. Int min inclusive, so including this minimum number, which is 0, right? Our array starts at 0. And then int max exclusive. So in our case, where animals, that length here would be 3. So that's 0 to 3, but 3 is excluded. So essentially, this will give us a random number from 0, 1, and 2, right? So para hindi kita mag-index out of bounds. But if we're using float, that's both inclusive. Min inclusive, max exclusive, if we are using float, which we'll do later on as well. But anyway, we'll create an object here. So we'll create an instance of this object from our animals, right? Animals, random index, and then position, we'll just say that this spawns sa position sa ating spawner, right? And then finally, we'll have quaternion for the rotation. Quaternion identity for now. And then let's go back to our inspector and finish up the remaining details. Okay, let's click on animal spawner here. Okay, so we'll see we have spawn rate there and we have animals here, 0 siya. And there is an arrow here meaning we can expand it. And it shows as a list. List is currently empty. So we'll add, since we have 3 animals, we'll add 3 elements. So currently none pa siya. And then we'll just supply it from our prefabs. So we'll just drag the cow to element 0, dog to element 1, and then stag to element 3. There, our array is filled. For now, our animal spawner, I'll drag it, so I'll make it visible for now. I'll drag it to scene, just so we could see. Maybe we'll drag it around here. Okay? And then we'll see what happens with our spawner, or with our animal spawner. Okay? Does it spawn? It's not spawning. Happening. It is not spawning. Ah, we don't have the we don't have the important part, which is time elapsed. Elapsed elapsed time, sorry. Elapsed time plus equals time dot delta time. Okay, this is important because this tracks the passage of time. I forgot about that. Okay, let's test it again. Oh, oh, it's too fast. Is it too fast? Where is the cow? It's at Z. For time the delta time forward. Oh, it's there. Why is it so fast? Our spawner. Wait lang. It looked too fast. Ah, there. So it spawns a spawner spot. Sorry. What I did wrong was I moved the child. I moved the child. So I'll reset, but I didn't move the spawner. So I'll move the spawner itself around here. Okay? And then play it again. Every second, this will spawn a random animal. We'll see, but it moves forward to the top of the screen. That's because we are spawning it with the rotation quaternion identity, right? So ang quaternion identity and rotation niya, we'll click on one of the, oops, sorry, one of the cows there. Oh, that's a stag, never mind. Ang rotation niya is there, may X siya, but essentially ang Y niya is 0, in which facing towards the top siya. We want to spawn this facing downwards. Okay? So we'll fix the script for that. Instead of quaternion identity sa animal spawner, we'll use quaternion Euler. There. And then we'll just input. So this accepts a vector 3 or just 3 values. So we'll have x rotation is 0, and then we want rotation sa y-axis, right? So this is 180 para mag-face siya downwards, and then 0 again for the z-axis. Okay. I'll move the spawner a little bit over here. And then let's see what happens now. There. So okay nang spawning niya, but it just spawns from one place. Then go overlap lang ang animals. Right? What we want is to spawn it at a random X na location. X lang man ang rotation because it should spawn somewhere at the top, right? I'll disable this again para invisible siya. Okay? And let's go back to the script. And then we'll have more fields here. I'll call it xmin. So similar no xmin and xmax. So this is the minimum x na spawning, and this is the maximum x spawning. We'll just do 1F for now, but we'll edit it. Actually, we'll just put minus 21 and 21 here because we already know that from our player, right? But we can use, we can still edit this through the inspector because serialized man siya. And then, before we instantiate here, we'll do float. We'll create, or we'll do a random x value, uh, random x value, uh, and then we'll use random range again. So minimum is x min and maximum is x max, and then we'll create a vector 3 sort of offset or sort of position. So let's say vector 3 spawn position. So for the spawn position, we want our random number. We'll just multiply it with a vector 3 dot right, which is in the x-axis, right? So meaning it's just a number, and then you multiply it with 100, right? So there, and then plus, not spawn rate, plus transform dot position. So essentially, this is the offset, right? The random value is the offset, and we're just adding it to transform that position, which is the position of our spawner. So instead of transform position here, we'll replace that with spawn position. Here. I'll erase that comment. We don't need that anymore. Okay. I'll just check. Animal spawner position 00 siya. Meaning it's minus 21 to 21 here ang spawning niya, right? Okay. And then, let's see. There, it now spawns at a random X na, oops, our cow actually disappears before it reaches the end of the screen. we'll fix that, right? We could just fix that through prefabs, right? Maybe instead of 5, let's do 7 para generous. Okay? Again, dog, stag, big cow, cow, stag. Yeah. So random ang exposition niya, right? And it's also a random animal. And we still have the throwing banana. But right now, we don't have collisions and collider interactions, so essentially it's just an incomplete game. But for now, we can stop here, and then we'll just do collisions next lecture naman. Okay? All right. Yeah, we'll do that sa Thursday.